Hi guys, this is Matt Brady here with graphing rational functions, or as I like to call it, graphing fractions with variables in them. Okay, so we'll go over all the steps about graphing rational functions. The two main rules that you always have to remember about graphing rational functions is that you can't cross the x-axis unless there's an x-intercept. So as you see in this example here, it never crosses the x-intercept or the x-axis unless there's an x-intercept. Okay? Second rule you always have to remember is the function can cross the horizontal asymptote but never the vertical asymptote. And then we'll learn more about what those are about in a second. So, x-intercepts are points that cross the x-axis. So you can help this helps you graph your function easier. So you take the numerator of the fraction and you factor and find the zeros. So if you look at this example, this would be for the numerator, x minus 3 equals x minus 3, which x equals 3. So therefore the x-intercept would be 3. That's the point where the function crosses x. The next thing you need to know is vertical asymptotes. Factor and find zeros the denominator, just like we did for the top. So in this example, x plus 4, and that equals x equals negative 4. Okay. A trick for this is each vertical asymptote has one side going up and the other going down, unless you have a double factor on the bottom or a factor square. What I mean by this is if you look over here, that's a factor squared on the denominator, and that means that they will end up going like that. But if you just had that x minus 3 over there without this, then you would have something like that, okay, on the left side with the arrows, or vice versa, okay? And that's a good trick to remember for vertical asymptotes. Next thing you need to know is holes. If the same numerator and denominator occur, then you have a hole in your factor, and then you have a hole, or if your factors cancel is another way of putting it. Holes are basically in your function. You have a hole, nothing can be there. So you get this if you have something like that as your function, x minus 2 over x minus 0. Well, you cancel those both out. That's 0. That must mean you have a hole. Okay, so that's always important to remember. Y-intercept, straightforward, the point where it crosses y, and this is important for graphing. Visually, this helps you know where you have to cross the y-axis, and you just do this by plugging in 0 for all the x's in the function. Okay, horizontal asymptotes. A graph must end at the left side and the right side of the horizontal asymptotes. What I mean by this is if you look at this little sketch here, then you see the dots there. Well, the graphs must end at the dots, so they either that one or that one or that one or that one, and you have to end at each side. Okay, that's where you have to end. So if you look at a function and the top exponent is bigger than the bottom exponent, then you have no horizontal asymptote, which leads to it being an oblique asymptote, where in that case you have to find the quotient of the top divided by the bottom and find y equals mx plus b, or your slope, so then you can graph the oblique asymptote. The next thing you need to know is that if your bottom exponent is bigger than the top exponent, then your horizontal asymptote equals 0, or the x-axis. The last case is if you have the same exponent, divide the coefficient to find the horizontal asymptote. So if you look over here, this is an example, 4x squared divided by 5x squared. Well, they're the same exponent, so then your horizontal asymptote must be 4 over 5. Okay, another case of that would be 2x over 7x. Same exponents on those x's, so it's 2 divided by 7, which leads to your horizontal asymptote being 2 over 7. Okay, I will now show you a little example of something I have done to walk you through a case of rational functions, or graphing rational functions, okay? So we're going to take the function 2x squared plus 7x minus 4 over x squared minus 4, okay? So first things first, factor the top. Okay, the factoring, I'm not going to go through that because you should all know how to factor at this point. The top leads to be x plus 4 and 2x minus 1 over x minus 2, x plus 2. Okay? So, first things first, find your x-intercepts. Take the top, factor, and find the zeros. Easily, you can do it just by looking at that. You get the x-intercepts of negative 4 and a half. Okay? So, you can put those on your graph. Negative 4 and a half. Okay? Next part, factor the bottom. Find the zeros for the vertical asymptote. Easily done. Plus or negative 2, both vertical asymptotes. Put those on your graph. The dotted line up the negative 2 and the dotted line up the 2. Okay? Y-intercepts, plug in x for the, or plug in 0 for the x. You can look at this now. 0 plus 4 and 0 minus 1. Okay? That's going to be negative 4. And then 0 minus 2 over 0 or times 0 plus 2. It's going to be negative, or it's going to be negative 4 as well. Because and that's going to give you 1. Okay, so because negative 4 over negative 4, that equals 1. That's your y-intercept. Horizontal asymptote, you have no special cases if you look at the top. Okay, they're the same exponents, so your horizontal asymptote is 2 over 1. Okay, so it's 2. Your horizontal asymptote is 2. You can graph that, putting it there. I like to draw the dots. This is what I meant by the dots. There and there. There and there. Okay, you can graph. As I said, you always have one going up and one going down, unless the factored version is square, which is not. So you got one up over here, one down over here. Okay, you know your y-intercept, you know your x-intercept, okay, and so if it's going down over here through this x-intercept, but it can't touch the asymptotes, then it goes down over here, okay. Well, if that one's down here, that means this one must begin at the top, because, you know, they're not factored at the bottom, okay. So this one starts at the top, going up, comes down, oh, it just broke through the horizontal asymptote. Is that legal? Yes, it is, because it's horizontal, not vertical. You come down, hit your y-intercept, you hit your x-intercept, come through, you finish down here. Where's the next one have to be? Oh, has to go up and be up here. So it's at the top of your vertical asymptote. It starts at the vertical asymptote. It's got to end at the end of the horizontal asymptote. That's why I put the dots here, because I knew I had to end at either one of those dots. Ends there. Perfect. Looks awesome to me. You put that in your graphing calculator. See what you get. I'm sure it's the same. And yeah, that's all I have to teach you about graphing rational functions. Hopefully you learned a lot, and please comment.